Okay, as I was saying, this right here is 4r plus 10. So the least common multiple of r plus 10 and 4 times r plus 10 is 4r plus 10. So our goal here is to multiply the whole thing by 1. The 1 we multiply is 4r plus 10 over 4r plus 10. This is 1. Our original times this. Now, in order to multiply fractions, I kind of need to know what's on the top and what's on the bottom. So I put these over 1. So this itself is a complex fraction. But on the top, I multiply these. And on the bottom, I multiply these. When I multiply these together, the numerators, I multiply across the top. I'll actually write it out over here. I multiply across the top. 9 times 4 times r plus 10 over r plus 10. That's my new numerator. And 5 times 4 times r plus 10. On my denominator, I'm going to use this one, 4r plus 10. Okay, so now let's look at the numerator. What actually happens here is that this r plus 10 cancels with this r plus 10. And my numerator becomes just 36. This 4 cancels with this 4. Notice how these things are all multiplied together. And this r plus 10 cancels with that r plus 10. All I have left on the bottom is 5. That's it. That's the answer. So here I multiplied by the least common multiple of the many denominators over the least common multiple, or a form of 1. Let's do number 11. Same idea. Notice how I'm adding these two, or I'm sorry, subtracting these two. So I'm going to use the same philosophy. This time I have 4 denominators. Well, these kind of match up, but let's see. Least common multiple of x, y, x, and y. Okay, that's just xy. So these guys, the x's are going to need a y, the y's are going to need an x. So let's see. Let's write this over again. Give myself a little bit more space. 3 over x minus 2 over y divided by 5 over x minus 4 over y. So give myself a little bit of space. This one is going to be multiplied by y over y. You know what? I'm not doing that right. I'm not doing that right. What did I say? My goal here was to multiply this whole thing by xy over 1 and this whole thing by xy over 1. So 3 gets multiplied by xy, 2 gets multiplied by xy because I'm going distributing, 5 gets multiplied by xy, and 4 gets multiplied by xy. Everybody got multiplied by xy. Now what's happening here is those cancel, those cancel, those cancel, and these cancel. And what I'm left with is 3y minus 2x over 5y minus 4x. What's it? Wait, what did I do? Okay, this is what I did. This is my least common multiple. This is my least common multiple over my least common multiple. I just put each of them over 1. This is 1 multiplied by 1. At the same time, getting rid of all those many denominators. That's okay, we'll do it again. We'll do it on number 12. Then number 11 was 3y minus 2x over 5y minus 4x. Okay, let's start here. We have the least common multiple of r squared, s squared, r, and s. I need to find something that all of these go into evenly. I need 2 r's and 2 s's. This goes into this evenly. So when I multiply by this, r squared s squared over r squared s squared, which is the least common multiple over the least common multiple. The only thing I could do in an expression is multiply by 1, or part pieces by 1. Now, let's see, we need to distribute this. So everybody gets multiplied by an r squared s squared. So this times this is 1 times r squared s squared over r squared minus 4 r squared s squared over s squared. 2 r squared s squared over r minus, I'm right here, 4 r squared s squared over s. Now let's cancel. These two guys go. This is a fraction that can be reduced. This is a fraction that can be reduced. This is a fraction that can be reduced just to r squared over r is just r. S squared over s is just s. So let's see what we got. This guy is just s squared. This guy, oh, I got a minus 4r squared. Down here, 2r s squared minus 4 r squared s. Okay. Recognize anything? I need to see if this can reduce. Well, this is s squared minus 4r squared. That looks like a difference of 2 squares, which can be factored into, and then the square root of this, I guess I could do a plus and a minus. Square root of this is I'm just rewriting it so you can see the square minus the square. Difference of 2 perfect squares. So this must be 2r and 2r. 2rs positive, 2rs negative actually drops out. Now, let's see. This is not a perfect square, and neither is this. This is in the way, and both of these are in the way. But it looks like I got a lot of r's and s's going on. So let me pull out a greatest common factor. I see a 2 in the number pieces. I see 1 r in the r pieces, and I see an s in the s piece. Now let me write down what's left. 2rs times what gets me 2rs squared? That's just s. 2rs times what gets me negative 4r squared s. I don't need an s. I do need an r. I'm working backwards this time. And I already have a 2, so that means I need another 2. And I need a negative sign. Well, lo and behold. See? These things are multiplied, and these are all multiplied. This factor cancels with this factor. Exactly. Which means the final answer is s plus 2r over 2rs. Complex fractions.